Hi students. So today we are going to discuss about confidence intervals. This is also requested by a student. Okay. So we'll see. The mean of a sample of size 20 from a normal population n. Normal population is denoted with n with mu and variance 8. We have to read this one as mean mu variance 8 was found to be 81.2. Find 90% and 95% confidence intervals for mu. So what we have to find out here? We have to find out confidence intervals for mu. Okay na? Manam confidence intervals for mu ki calculate చేయాలన్నమాట. Okay? So దానికోసం మనం ఇచ్చిన డేటాని రాసుకుందాం ముందు. Given that sample size. What is the sample size? Here 20. So sample size is denoted with n. So 20. Next, sample mean. Sample mean. Sample mean is denoted with x bar equals to how much here? The mean of a sample of size 20 from a normal population was found to be 81.2. So the sample mean is 81.2. Okay. And next is here they gave normal population with mean mu and variance 8. Okay, so here 8 is called with mean mu and here 8 is called as standard deviation. Okay, so population standard deviation, it is denoted with a sigma that equals to 8. Okay na? So now what we have to do is we have to find out the confidence intervals for 90%, 95% anamata. Okay, so confidence interval formula. Okay, formula. First we'll write the formula so that what we have to calculate we'll understand. Okay, so confidence interval formula. So the formula to calculate confidence interval, I am writing in short form, confidence interval for population mean. Population mean, they asked for mu, no? That means population mean, no? This is for population mean when population standard deviation is given. Okay, they gave us standard deviation, population standard deviation they gave, and they are asking to find out the confidence intervals for mu. So that's why the formula is given. So the formula is x bar plus or minus z alpha by 2. Here the level of significance alpha by 2 into sigma by root n. Okay, so this is the formula. Okay, so now we'll substitute the values. So see here, x bar in the sense we already know 81.2. Next sigma in the sense 8 we know, and root n value also root 20 we can find out. Now what we have to find out is we have to calculate alpha by 2. So for that, at 90% we can say, or else we can say 10% also. Okay na? At 90% the table value, the critical value, what we have to take is, so alpha, that means 90%, the table value is 0.10 we'll consider. Okay, the critical value we consider 0.10. Okay, but here they asked alpha by 2. Okay, alpha by 2 in the sense what? Alpha by 2. That means what? 0.10 divided by 2. Okay, so that means how much we'll get? 0.05 we get. Okay, so the critical value, that means table value ma, the critical value Z alpha by 2, that means 0.05. Alpha by 2 in the sense 0.05, no? That equals to 1.645. Okay, or else we can say this 0.05 as 5% also we can say. Why? Because 5% in the sense what? 5 divided by 100. That is nothing but 0.05. Okay, so at 5%, or else we can say it as 95% also. Okay, why? Because 100 minus 95 is nothing but 5%. Okay, the table value is 1.645. Okay, so now we have to calculate what? Sigma by root n. Okay, this is called as standard error. We can say it as a standard error. Okay, so now to calculate standard error or else standard deviation also we can say. Standard error is nothing but in other forms we can say standard deviation, but here root n is there, no? So that's why we call it as a standard error. Okay, standard error, it is denoted with sigma. Standard error equals to sigma by root n. Okay, sigma by root n in the sense what is sigma value here? 8. So 8 by root n, what is root n? Root 20. So we'll see how much the answer is. So sigma by root n. So 8 divided by root n, root 20. So 1.7889. Okay, 1.7889. Okay, so now again see, this part is called as standard deviation. As I told you, no, this part is called as standard error. Sorry, this part is called as standard error. The whole part is called as margin of error. Margin of error. That means simply we can write this formula as x bars plus or minus margin of error also you can write. Okay, margin of error in the sense what? This whole part will come. Okay, this only this part is called as standard error. The whole part is called as margin of error. So now we are going to find out this value. So that means margin of error. So margin of error. So margin of error is denoted with ME. Okay, ME is called as margin of error. That equals to Z alpha by 2 in the sense what? Z alpha by 2 in the sense how much we got? 0.05 value. How much it is? 1.645. Okay, so 1.645. 1.645 into sigma by root n, that means standard error. How much is standard error? 1.7889. Okay, so we'll see how much the answer is. So 1.7889 into 1.645. How much here? 2.9427. 2.9427. Okay. Yeah. Now what we have to calculate is, now we have to calculate confidence interval. Okay. Confidence interval. So confidence interval, what is the formula for confidence interval? X bar. X bar in the sense what? X bar in the sense what? How much we got X bar here? 81.2 plus or minus. This is called as margin of error. What is the answer of margin of error? 2.9427. So we will write 81.2 plus 2.9427 comma 81.2 minus 2.9427. Okay, so we'll find out. So 81 plus 2, sorry, 81.2 plus 2.9427 equals to how much? 84.1427 comma 81.2 minus 2.9427 equals to how much? 78.2573. Okay, so this is about 90%. Now what we have to calculate? We have to calculate at 95% now. At 95%. Okay, so at 95%, so the 95% means alpha value how much? 0.05. As I told you, 95% is nothing but 100 minus 95 is 5%. So 5% in the sense what? 5 divided by 100, that is nothing but 0.05. Now alpha by 2 we have to calculate. No, alpha by 2 in the sense what? 0.05 divided by 2, how much we get? 0.025 we get, isn't it? Yeah. Now the critical value at Z 0.05, critical value is nothing but table value, Nana. Okay, so 1.96 at 5%, at 0.025 we get 1.96%. Okay, now what we have to calculate is standard error, SC. What is standard error formula? We all know that sigma by root n is standard error formula. So sigma in the sense what? 8 by, already we calculated now. So okay, root 20. How much this answer? 1.7889. Why? Because before we calculated. And here margin of error we have to calculate. Margin of error in the sense what? This table value. What is here table value? 1.96. Okay, 1.96 into, already we calculated sigma by root n. That means how much? 1.7889. So that equals to, so 1.96 into 1.7889. How much? 3.5062. Okay, 3.5062. Okay, so now what we have to calculate? So now we have to calculate the confidence limits. So confidence limits, or else we can say confidence interval. So confidence interval. So what is the formula for confidence interval? X bar plus or minus Z alpha by 2. That means margin of error. Okay, margin of error. So X bar in the sense we all know that X bar value is 81.2, isn't it? So 81.2 plus or minus, we got here margin of error value, how much we got? This all comes under margin of error, no? So margin of error value, how much we got here? 3.5062. Okay, so now how we'll write this one? So 81.2 plus 3.5062 comma 81.2 minus 3.5062. So we'll see what is the answer. So 81.2 plus 3.5062 equals to 84.7062 comma 81.2 minus 3.5062. How much? 77.6938. Okay, so if you observe these both values, this 90% confidence interval and 95% confidence interval, if you see there are similar answer, isn't it? So 84. So the rest of the thing is in decimals, Nana. So mostly we don't consider. So here 78, here 70, that means near answers we got. Okay, so that is about today's class, ma. So the confidence intervals are this one, this one. This is about 95%, this is about 90%. So hope you understand. So Nana, there may be one question. Why mostly we consider, see in the question, if they don't give any level of significance, we consider at 95%. Why we have to consider at 95% only? In the sense, Nana, most of the cases at 95% we get the true values. See, I'll give one live example for you. So why we have to get pass marks, that means pass marks, why they fix only for 135, for 70, 28, like that, why they fix all those values? Because after going several research, they keep that one. So like that only, if they don't give any level of significance, we have to consider it as 95%. We are going to take the table value. Okay, that is a simple example I want to share with you. Okay, yeah. So this is about today's class, ma. Hope you all understand. So keep watching. Thank you. Have a nice day. Bye. Take care.